In the last session, we had talked about MAC addresses, switches, hubs, bridges, and today we will be knowing about the IP addresses. Okay, routers, different IP services, access control lists, and many more. And okay, first one is IP address. What is the IP address? We all know IP addresses is unique identifying network. Every router and every host have a unique IP address by which we can identify that particular device, an entire globe or entire network. Okay, we can route our data packets to that device using IP addresses of that device. Okay, addresses are of different kinds. It can be private or public. It can be okay. In private public, we will be knowing further. IP addresses are divided and classified in two categories as per their version. That is, the first one is IPv4, that is IP version 4, and another one is IPv6, that is IP version 6. Now we will be knowing about IPv4, and later we will be knowing about IPv6. Okay, that's more forward or today's session. Okay, IPv4, that is Internet Protocol version 4. It was introduced by ARPANET in 1990s. As we know, MAC addresses of 6 bytes, that is 42 bits, sorry, 48 bits. Similarly, IPv4 is of 4 bytes, that is 32 bits. Okay, and it is represented as decimals with dotted. Okay, now with a decimal notation. IP addresses are assigned by IANA, that is Internet Assigned Number Authority. And IPv4 addresses consist of two parts. That is, for the first one is network part, and the second one is host part. Here, the IANA allot the network part. Okay, and the host part is allotted to each allot, allotted to every devices by the routers or default gateways. Okay, in this maybe this is a network part of which is allotted by IANA. Okay, actually it is the organization have to pay for every IP addresses. Okay, here this part is allotted by IANA, that is network part, and this part is allotted by the default gateway or router to a specific host, which makes the it unique for a specific device. Which okay, here you can see every byte has represented in the form of decimal and different with dotted dots. Okay, this type of notation is called dotted decimal notation. Now we will be knowing about classes in IPv4. What are classes and why it is needed? See, um, INA provides an network address to a router, okay, which can be of 8-bit, 16-bit, even 24 bits. Okay, we will be knowing about different types of classes, that is class A classes, B class, C, and many more. Okay, well, saying the INA allowed network address to the router, and the router or the default gateway have to allow to uh, uh, a unique address to every host. Uh, okay, suppose this is a network address provided by the INA to a router. Okay, this is the default mask. Okay, in the form of binary. This is default mask in form of decimal. Here, here, this address is given to a router as a network address by INA. Okay, now The router would distribute this address to multiple hosts. Okay. Now, suppose the router have to distribute this address in three hosts. How it would distribute? Uh, it would be like in the form of host A would router can give host A address 192.168.1.0. Similarly, B and C will get 192.168.2.0 and 192.168.3.0 respectively. Okay, the INA can allow to any byte as a network address. It can load the first byte, it can load the second byte, the first two byte, and it can load uh, the first three byte as a network address, and last okay, and the remaining would be the host, uh, and remaining would be reserved for the host. Okay, it is class A. Okay, in class A, the first byte of the address is the network address, and the remaining three byte is the host is for reserved for the host. Okay, the range of class A is 1.0.0 to 126.0.0. Okay, and the default subnet mask, uh, uh, as we discussed earlier, it is a representation of the network address and the host address. Uh, where the 255 is the network address, and the 00 is for the host address, and it is a notation. When we write IP address, if I represent it like 8, then it would say the first 8 bit, the first 2 byte or 8 bit is the network address, and the remaining is the host address. Okay, the number of networks or number of addresses that can be um, provided, that can be given by a class A, that in class A is uh, 128 to the power 7 minus 8. The number of addresses that can be provided by class A, the number of network addresses that can be provided by class A is 128 into to the power minus 2 to the power 7 minus 2. The reason of minus 2, here the 2 to the power 7 is due to the number of bits. Okay, and here the reason of minus 2 is the for example, 1.0.0 is reserved for the representation of the network. Okay, and the 1.1.1.1 is reserved for the uh, broadcast. Okay, that's why here we uh, that's why here we do minus 2. Okay, in entire number of networks, and we know that um, network address is of 32 byte, in which the 8 byte is for the network address, and the remaining um, 24 byte is for the host address. So we can again calculate um, uh, 16 sorry, here the number of networks was 128, which has been 120. The number of networks was 128, and the usable number of networks was 126. Okay, and the number of hosts per network, but means in one network of class A we can connect 16 lakh 7 sorry 16 million uh, hosts. Okay, Here again, the minus 2 is due to the represent the dotted 0.0 is for the um, is reserved for the network address or network representation of network, and the 1.1.1 that is reserved for the broadcast. Okay, that's why the number of hosts per network is 2 to the power 24. Since the 24 a bit is reserved for the host, so it is 2 to the power 24 minus 2. Okay, and is designed for very large network. Obviously, uh, it is in a network there should be a 16 million hosts. Okay, this is unpractical a little bit. Here it is class B. Okay, in which the first two bytes are considered as network address, and the another two byte is reserved for the host. Okay, host address. That is, the number of network that is possible is 2 to the power 14. Okay, and the number of hosts per network is possible, 2 to the power 16 minus 2. Again, the minus 2 is due to the I had explained in the last slide. Okay, and this is for the reserved for the representation of network, and the 111 is reserved for the broadcast. Okay, since the network address is of 16 bits, so the notation is of 16 bytes. Okay, it's represented like this. Okay, that means the first two the first two are the network, and the another two are the host address. Okay, the another is class C. Okay, again, the default subnet mask is uh, 255 255 255. That is, the first three byte is for the and is reserved for the network address, and the last byte or the remaining byte is reserved for the host address. That is, uh, the range of the class C is 192.0.02 to 223.255.255.0. Okay. Um, it's the notation. Here it is the notation. Okay. Here you can see uh, the first three byte is the network portion, and the last byte is for the host portion. Okay, it is represented 255.255.255.0. That is, it's a subnet marks. Okay, um, its notation, it can be noted as 24. It means the first 24 bit is contains the network portion, and the last 8 bit contains the host portion. Okay, the number of networks possible in this class C is 2 to the power 21. Okay, and the number of hosts per network is 254. Okay, again, the minus 2 is why we know it. It is the most practical class in which there are around 254 hosts, and it means subnetting and why it is used. As the term defines, subnetting is a big network is divided into different subnets. Okay, for example, a college is a big network. Okay, and there can be a subnets of admin block, different departments that can be that can be a subnet. Okay, so uh, it is called uh, VLANs, that is virtual local area network. Okay, that is uh, uh, local area network is this, and the local area network is divided into four different virtual networks. That is, and okay, that is called VLAN, virtual local area network. And that is VLAN 1, VLAN 2, VLAN 3, VLAN 4. Okay, this process of of breaking down a large block of network into different networks, different subnets or subnetworks uh, is called subnetting. No, it's called actually what is subnetting. We will be knowing in next slide. Okay, here you can see this is the router which is connecting the entire network with the internet. Okay, let's understand it in very easily. Okay, mm. Suppose it has got an IP our network address as AB0.0. Okay, now we have to separate these two networks as VLANs. Okay, this is a local area network, and this is two separate network, that is two different VLANs. Okay, VLAN 1, VLAN 2. Okay, suppose a router has to allot a different allowed network address for VLAN 1. What it would do? It would do a dot b dot something like c dot 0. Okay, and the remaining part which is empty or which is 0, they would be the host address. Okay, for this VLAN, this a dot b dot c, the c which has been allotted by the local router, for this network it is considered as the network address. Okay, that is, it would be fixed. Okay, and all the hosts would be in would be all the host address would be putting here. Okay, this is subnetting. Okay, and that is breaking down of network address into different subnets according to uh, different VLANs. For different VLANs is subnetting. These are two types. One is fixed length subnet mask. Okay, here you can see it is the network address. Okay, of the IP. It is the network part of the IP address. Okay, and the local router has allocate different IP addresses, or it, you can say a virtual network addresses for different subnets. Okay, here it is 192.168.0.0 for the first similar for dot. Some changes has been done for the different subnet, and here the fixed length is due to what all the in this uh, it is considered that all the virtual networks are of same size. Okay, but the number of hosts in the each virtual network would be same. It is considered in this way, which is not particularly which is unusual and unusual. There can be a host of 1000 in one virtual network, but there can be a host of only 20. Okay, in this way, many IP addresses can be wasted. Okay, so there has been introduced a technique of variable length subnet masks (VLSM). In this technique, every virtual network can be of different types. Okay, for example, okay, For understanding it, it is quite difficult to make you understand in this slide way. I'm leaving the explanation. Okay, um, just understand. Here, it is the network address provided by the INA. Okay, for subnet one, the router allotted this network address. Okay, virtual network address. For subnet two, router allotted, and so on. Okay, it is, you see it is a variable. It is a variable length, that is it can, the subnet one can have 64 addresses, subnet two can have 32 addresses, and even subnet 4 can have 4 addresses only. Okay, the question is, for now, let's understand it by here. Here the difference is 64. Okay, the difference is 16. Actually, I don't know what it is. IPv4 summarization. Okay, it is the process of combining multiple IP addresses or networks into a single summary route. Here you can see, here different IP addresses of different subnets. Okay, 192.168.0. Here you can see clearly that 192.168 is common in every network, and we all know what is common. That is the network part is a common for every IP addresses. Okay, and it is uncommon part. Okay, this is not common. So the summarized route can be 192.168.0.0. Okay, for now, understand it. All the techniques like classes, different classes, subnetting, NATs are used, are has been introduced because of the limitations of IPv4. It cannot uh, exceed the number of IP addresses. Okay, up as the limit would be touched. Okay, so the new version of IP has been introduced, that is IPv6, IP version 6. Okay, in this IP version 6, it is of 128 bit, that is of 14 bytes. It's all due to the lack of IP addresses. Okay, let's in IPv4 it can generate up to 429 into 10 to the power 9 addresses, IP addresses. But in IPv6, it can generate up to 10 to the power 38 addresses. Okay, see the difference. The one is 10 to the power 9, another is 10 to the power 38. Okay, address of IPv6 is represented in hexadecimal, where the IPv4 was represented in decimals. The IPv6 is the header has 40 bytes, where the IPv4 header have 2260 bytes. Okay, so listen. IPv4 supports a variable length subnet mask, which I studied in the last slide, and where IPv6 don't need to have any kind of realism. It already have so much space or so much number of IP addresses. Okay, what is routing? The process of choosing a path across one or more network is known as network routing. The device which involved in routing is called the router. Its function is to route, or its function is to direct a data packet from one node to another. Okay, let's take a basic overview of routing. Here, the message is passed mass. messages or whatever. Here, the data packet is passed to the nearest router and it passes to our different routers and goes to the destination. Okay, this process of passing the data packets from source to destination between multiple routers is routing. Okay, three types of routing, that is static routing, dynamic routing, and default routing. Okay, one is static routing. See, there is a multiple path between source and destination to provide the data packet. Okay, in a static routing, the network administrator decides which path is going to be used. Right? In this routing, the network administrator has full control over the network. However, it may not be suitable for larger scale enterprise networks. Okay. The second one is dynamic routing. In this type of routing is an autonomous procedure without any human intervention. Packets are transmitted over network using various shortest path algorithms and predetermined matrices. It is also called as adaptive routing. Basically, in this type of routing, the routers between source and destination decides itself which path is going to be selected, which path they will select. Okay, there is no any human intervention. So routing protocol is to learn about all the available paths to route data packets. The first one is distance vector routing. As we explained earlier, the router decides itself which path is going to be selected for routing the data. Uh, the routers use distance vector routing calculations to calculate which path is suitable for them, which path is shortest for them. It is a sender and receiver. In a static routing, the administrator decides the path. For example, the administrator decided this path to route the data. Okay. In dynamic routing, the so the sender and the receiver nearest router decides which path is shortest or which path is more feasible for them. For example, in this network, this path is shortest path. Okay, and then they will route the data from this path. Sorry, this path is the shortest. Now let's know about different API services. The services like DHCP, ARP, DNS. Let's know about its functionalities. Okay, the first one is DHCP services. DHCP, that means Dynamic Host Configuration Protocol. It assigns IP addresses to a devices who is newly connected to a network. Let's understand its working. Suppose A is a device or host which is newly connected to a router. Okay, currently it doesn't know the IP address, its IP address. Then what does it do? It send a message to uh, DHCP server. Actually, it doesn't send only to the DHCP server. It sent a broadcast message to every connected devices. Um, it asks for its IP address to every connected devices. Actually, here and the other end there is a DHCP server. Okay, receives the message and reply back mentioning its IP address. Okay, here uh, the source address is the source IP address is 00 and destination IP address is a broadcast address while questioning. Okay, and while replying, the source uh, address IP address is DHCP server IP address, and the destination IP address is host IP address. In this way, the host gets its IP address. As a host gets its IP address, it again sends some message to DHCP server that it has been accepted. The IP address has been accepted. It is because sometimes host can get more than one IP address by different DHCP servers. This is how DHCP protocol works for assigning IP address to devices connected to a network, newly connected to a network. Now we will be knowing about ARP services, that is Address Resolution Protocol. Basically, with the help of this protocol, a host can know the MAC address of a device which is connected to host can know MAC address of a device with the help of its IP address. Okay, this protocol come into role when a device wants to communicate with another device within the same network, but only knows the IP address of the destination, and the device use ARP to find the corresponding MAC addresses. Suppose here in this network, A have to send a message to C, okay, but A does not know the MAC address of C, but IP address is known to A. So it to forward a broadcast message uh, or packet to in his the IP address of A, that is IP address and MAC address of source is mentioned, and the IP address of destination is mentioned. Um, okay, since it broadcasts the packet, so when she gets the packet and see its IP address, then she reply back using its source IP address and MAC address. C reply to A with a with a MAC address. Okay, and thus A gets and thus host A gets the MAC address of the C. Similarly, if suppose A wants to know the MAC address of Z, which is outside the network, it do the same process. A sends the message to router A, router let's assume M N. Okay, A sends the message to router M with same configuration, uh, having a header in which the MAC address and IP address of A is mentioned, and the IP address of router M is mentioned, but still IP MAC address is unknown to A of router. Again, the router sends A the MAC address of itself. In this way, the message the, similarly M sends the message to router N uh, with same configuration that mentioning the IP, the source and MAC IP and MAC address of router M, and the IP address of router N. Okay. Again, M comes to know about the MAC address of router N as it replies. Again, this router N provide the message to N. And similarly, as in this way, router N host A gets the IP information or MAC information of host Z. Okay, This is how ARP works. Let's know about DNS. We can't use IP addresses to access a node always. So we use names like google.com, facebook.com to access the nodes. Okay, these are called the domain names of a web browser like google.com and facebook.com. Here the DNS works is to translate that name into the corresponding IP addresses. When we type for example, google.com on our web browser, it first checks to the cache whether the IP address of google.com is present on the cache or not. If it found there, it there would not be. If it found there, it will go through and it will access that. But if the IP address is not found on the cache, it asks to the root server. Okay, it has directory of different kinds of domain like .com, .org. Okay, and so it is google.com. Then it forward the request to .com directory, and there is a list of different .com domain names. Here it is kind of directory in which the IP addresses of all the domain are present, and through here IP address is present. It resends to the this directory resend IP address to the root server, and the root server put the IP address to the cache, and it go to the surface. It go to the website, and finally user can access that website without knowing its IP address. Let's know about NAT, that is Network Address Translation. This technology is used to overcome the IP address deficiency in the world. To access the internet, one public IP address is needed, but we can use a private IP address in our private network. The idea of NAT is to allow multiple devices to connect the internet through a single public address. To achieve the translation of public IP address to a private IP address to a public IP address is required. NAT is a process in which one or more local IP addresses is translated into one or more global IP address and vice versa. NAT says in an organization should use only one public IP address and connect the entire network and internal network with a private IP address. All the private IP address should be connected to a pub, that NAT, which is having the router having NAT, which is having the public IP address. Here in this picture, you can see uh, there is a host. There can be multiple hosts in organization. There are multiple hosts, and it may be a virtual uh, VLANs, multiple VLANs too. Okay, the IP addresses provided to the host is a private IP address. Okay, private in the sense it can be it is not unique. It is unique in only in this organization. Okay, it, outside this organization it can be present. Okay, um, and these hosts are allocated a private IP address where this router having NAT is provided a public IP address. Public IP address is public IP address is unique in globally. Okay, there is no other IP addresses IP address like it. Now let's understand how it works. Okay. Suppose that this host have to access uh, this host, which is connected with these routers having NAT and the internet. Okay. Um, it had suppose um, this host had to send a message to this. It what it would do? It would uh, first in the IP packet in the packet message packet. It would mention the IP address and MAC address of this host and the that is source and IP and MAC address of destination. Okay, as the packet will move to the NAT. Okay, since and the since it is a private address, the NAT convert the source information that is private the NAT here replace the private address with this public address and forward it to here. Again, again, it it routes or somehow it routes to the router 2. Again, do the same. Um, here, it has come with a destination address of. This is how NAT works. Okay, there are three ways to configure NAT. Okay, the first one is static NAT, the dynamic NAT, and PAT. The first one is static NAT. In a static NAT, a single private IP address is mapped with a public IP address, that is one-to-one mapping between local and global addresses. This is generally used for web hosting. These are not used in the organization. There are many devices because there are many devices that will need internet access, and to provide internet access or to provide internet access, a public address, IP addresses is needed. In dynamic NAT, in this type of NAT, an unregistered IP addresses is translated into a registered IP addresses from a pool of public IP addresses. That is, you can take an example of an organization where a pool of private IP addresses is converted or translated into a single public IP addresses by the NAT. It comes in dynamic NAT. Okay. And another topic is ACL, Access Control List. Let's understand it by an example. In a building, there is a guard. There is a guard. Uh, if we provide a list if we say the guard that this a person of this name should not leave this building, or person of this name should not enter the building. Okay, what would happen? The person would not leave or enter the building. Okay, isn't it? Similarly, in networking, we can introduce or interface SCL to our routers. Okay, where we can provide a list to our router in which we can say a person of this IP configuration, sorry, uh, data packets or data of this IP configuration should not enter into the network, or a data or packet of this IP configuration should not leave this network. We can do it like that. Okay, this is ACL, that is access control list.